Hello, everyone. Welcome once again to yet another live stream with the famous Louis Trumpler. Now he becomes famous. I kidnapped him for so many live streams now that he has become a regular. Guys, before we start, before we dive into this in today's topic, please leave me a comment and tell me if you can hear us. That would be the most important thing first, right? If you can't hear us, then we have a big problem. Um, and I would like to know that. Let's see if I can hear myself as well. Let's see, unmute. Yeah, yeah. So I can hear myself, but I hope to get some comments. And after that, like as always, please press on that not refresh, repose button so that everyone in your network or some people in your network, hey, Jeron, thank you so much for joining. So your friends can also attend to this, okay? And don't worry, if you don't manage to stay for the entire session, I'm going to publish this on YouTube after that. But for now, just press that repose button and ask questions. Like during our chat, don't hesitate, just ask questions because I'm going to cover everything at the end of the session, right? After Louis goes through what he has to share, then I will cover all the questions and we are going to answer them. Welcome, Louis. Thank you very much again for joining me.
Pleasure to be back. Thanks.
All right. What are we going to do today? What are you going to show us?
We are going to explore the exciting world of life cycle assessment. And I've prepared a short presentation just to kind of set the stage. You should be able to see that, right?
Let's see. Yes, I can see the website.
Perfect.
Or I don't know if it's a website or just a
Yeah,
keynote.
it's my
It looks
my
like a
title
website.
slide. I was lazy.
It looks good.
Yeah, we are looking at IFC LCA today, and I just thought for this all to kind of make sense, it's good for me if I explain a little bit of the background of this project. And I also have to introduce myself for those who don't know me. I'm Louis. I work from Zurich. I have my consultancy and also BIM development company here. Feel free to check out my website, and there you can find most of the tools I work on. I am the maintainer of some free and open source tooling around IFC and also sustainability, the topic of today. I quite often get asked, how expensive is sustainability? Have you heard that before, Petru?
Oh, don't get me started.
Yeah, it comes up time and time again. And I, or it's my, I kind of looked into an interesting aspect that I feel is kind of enlightening when it comes to that topic. If you look up concrete prices, it's pretty much the same all over Europe. It's about 22 cents, Swiss cents per liter of concrete if you break it down, more or less, give or take. If we compare that to a liter of water, it's astonishing to see that a liter of water is at least 3 times cheaper than a liter of concrete. And that brings me to the conclusion that I believe sustainable construction isn't expensive or too expensive, but rather the status quo or business as usual is way too cheap because unfortunately we are simply not paying for the true costs of our bad choices.
I
And
love
I'm
it.
not saying concrete is bad, but it is a fact that there are construction materials that contribute to environmental that have a lot of environmental impact, and oftentimes this isn't really reflected in the costs, which is unfortunate, but it kind of explains why we are in the situation that we are in currently.
Yeah. And we don't have enough urgency at all. Unfortunately, most of us are still ignoring this reality. This reality, most of us are still ignoring it. There are some policies which are way too slow, and the implementation is even slower. And everyone just tries to drag this conversation as long as possible without actually doing anything. Sorry for breaking this to the whole party, but that's the reality. That's the reality that I see. And if you want to include even the quality of the models where this information should be, we don't have even a conversation because I still didn't see any models that have all the information required to do these calculations. I'm sorry, but that's the true reality. And I'm talking about from a place where IFC models were at the core of building projects.
Great. Thanks for your perspective. Yeah, this kind of goes into that direction. There's clearly some challenges around sustainable construction. Our industry is very resource intensive. There's just no way around it. And the regulations that we tend to adopt more and more are often kind of fragmented and not very rooted in actual practice. And as you've said, even on like the implementation side, there's a lot of room for optimization. So the special or the the niche that I'm trying to tackle here is to better integrate BIM with sustainability assessment or the so-called LCA. So what is an LCA? Well, an LCA can be a lot of things. It's basically when you evaluate the environmental impact, and that can be anything from a t-shirt to excavation on a construction site to even whole building LCAs. And that's what I'm doing with IFC LCA. I am focusing on the construction materials. So this is not looking at the building when it's in use, so not the HVAC energy consumption and that, but rather what goes into constructing that building or that structure. And what we want to do is to kind of get a price tag, but not to have the dollar signs at the end, but rather the CO2 equivalent that this building has as a footprint. So you might ask, well, how can I calculate that? And the nice thing is it's not rocket science. If we want to do an LCA, as I've said, we can look at CO2 equivalent. That's usually the main thing that we look at. And in order to calculate that, we need to have material quantities and we have some kind of indicators for that material, which means a certain quantity of a material is responsible for a certain amount of environmental impact. That usually comes from manufacturing, from raw material extraction, etc. So if we break it down, we need materials and we need carbon indicators. And if we break it down a bit further, we realize that those indicators come in the form of per kilogram CO2. That's just how they have it in the database. So if we look at our models where we usually have cubic meters of materials, we already have to do a little calculation where we use the cubic meters and the density. So in reality, we also need densities. And luckily, that's mainly available either inside our models. So in IFC, we can read out cubic meters of material used. If we have some sensible naming of the materials, which is one of the only requirements that I have for IFC LCA, you can have layered materials, you can have single materials, whatever, but please name them in a sensible way. If you only have default as a material inside your model, it's going to be really tough to perform an LCA that makes any sense.
Sure.
Also, currently, I target a material specifically. So if you have in your model, if you have like different concrete grades and you want to use a different LCA material for that, currently you'd have to use different material namings in IFC. So IFC LCA targets material names in IFC directly. Then I use the Swiss Carbon database currently. I am working on adding a Cobaudat, which is the German equivalent, and those give us the indicators for the materials, and in the case of Switzerland, also the densities. That allows us to perform an LCA, and if we go a bit deeper into how that is usually done, I see, and literature confirms that I see three main categories. The classic manual process is where someone sits down, gathers all the PDFs, generates a manual quantity takeoff, has to look into material specification, dig deep into different specialist document to really be able to manually generate or calculate the material weights and then to estimate the environmental impact based on factors from a database. That usually happens in Excel, and that's just the way I started. I like this process because users usually know exactly what they do, and if things go wrong, it's usually their fault too. So, and if you compare that to like a semi-automatic process that we have established in some of the larger tools, I'm not going to name any, but they have integrations with Revit, etc., that you can look at. There we get the bill of quantities from models, and then the user usually semi or fully manually matches those materials from model with actual materials from a database. There's usually a lot of visualization. 3D can assist this process greatly, but it becomes very crucial that the user knows how those matches get applied, and even down to the densities of actual materials, because these do matter. And it's very easy if you follow a semi-automatic process, as I do with IFC LCA, to kind of overlook some stuff and maybe not get an as detailed LCA. But the big benefit that we get, especially in a fully automated process, is that we just have less manual input and that it allows us to kind of get an instant LCA. So we can have much bigger throughput or much quicker throughput. And I would say oftentimes this can be worth losing some of the granularity or of the really detailed analysis that a sustainability professional would do for you. But of course, as automation gets bigger, I would say it's even more crucial that users kind of understand the fundamentals and learn how to work with those tools. Because just having a fully automatic material matching, from my perspective, might work on structural models where we have a limited variety of materials.
Yeah.
But if we go into the architectural domain, and also if we go a bit earlier stage planning, then this gets really fuzzy, and we have to be careful to still be able to get accurate
Mhm.
results. Sorry. That brings us to my short demo where I would encourage you to try it yourself, ifclca.com, and I will switch over to my browser. If there's any questions so far,
Not yet.
we can
No, not
address
so far.
them.
Oh, actually, somebody asked something, or says something. Not all LCAs are based on cubic meters, but also based on square meters or linear meters. Is this supported?
A very good question, and no, currently not. Or I am currently looking at materials in IFC, and that means your wall, if it has a multi-layer build-up, I am looking at individual layers and I calculate cubic meter per layer in
The volume,
floor
yeah.
and walls, which means that your model has to have a certain degree of detail. I am aware that this is kind of uh, this is this renders it pretty useless for some people, especially as I said, in early stage architectural planning, where we sometimes just have rough volumes of walls. But we could use a standard catalog where there's different wall build-ups for early phases, and I'm working on that. This way, we can kind of combine the two worlds and get the best of each. In early stage and architectural models, I am working on adding a square meter based calculation engine where you can either have your own build-ups, so you can create your floor, slab layers, etc., and your wall section build-up. But I find it even more interesting that we then get to use those ready-made catalog build-up libraries, which makes a lot of sense in early stage, but is currently not supported yet.
All right.
Great question. Thanks.
Yeah.
And the linear one, I haven't really thought about. Feel free to reach out if that's something that's interesting for you. That would be like a meter of something, I guess.
Mhm.
I tend to prefer the like the cubic meter and material approach, but very open to discuss that. Feel free to reach out. Yes.
Good.
So if
We can,
there's
yeah, I think we can move on and start with the demo.
cool. Um, if you look into IFCLCA, it's free, it's open source. You can have a look at GitHub and the code base here. If you dig into the code, you will realize that it runs client side, which means I don't save any IFC. What I do save is your material matches and some stuff around your account. But yeah, any IFC data stays on your side.
Yeah, for everyone
I've
who is concerned about privacy.
rightly so. Privacy is important, especially with big models or with IFC. Yeah. So I've prepared a demo project. You can do this yourself. You can have 3 projects currently, just to limit the load on the DB a bit. And if you set up the project, you see that it's totally empty, but you get tempted to upload an IFC, which I will do. Just show you which one I'm currently using. It's my trusted BIM Collab demo model. This time I'm using the architectural one because it works quite well. I will drop the file in. It takes a little while because there are quite a few elements inside that model, especially those curtain wall elements
Yeah.
that come in as separate parts. But when it's done, we get forwarded to the material library where you can set up your personal matching. So you have your materials from IFC on the left side, and we have the materials from our database on the right side.
Mm.
For now, the Swiss KBOP, but I will be expanding that pretty soon. So it looks at naming, and in this model we have English material names, which gives us, yeah, I would say some funky coordination, some funky matching, but it does sometimes find the correct one. I'd say this gypsum and
Mm-hmm.
Gipsfaserplatte is pretty much perfect.
Mm-hmm.
Um, I'll just go through and accept those for the sake of the presentation. It will result in an LCA that will not really make
Mm.
sense.
Yeah.
But
Quick,
for the
quick
sake of
question.
today's presentation,
Quick,
yeah,
quick, quick suggestion, maybe. Maybe you can add a button, accept all.
accept all. Yes, it's on the list.
Okay, cool.
Um, we For some materials, we can adjust the densities. That's just how legislation is in Switzerland. That's pretty much a local thing. For others, it's defined. We can confirm and go to project. If we upload the next IFC, it will automatically do those matching again, so we don't have to do it each time. And here we're back to the project overview where we see that we have some emissions calculated. We have elements populated and materials. We can see our upload list. If I work on that model, upload it again, it will keep the elements and it will update calculations. So if your walls get bigger, etc., or smaller, it will change the environment. So you can actually work on a project over time.
Mm-hmm.
You can have a look at elements that were parsed from that model. We can have a look at the most, like we can sort by volume, and we see that those limestone walls, they seem to be pretty dominant in that model. And if we go to the material tab, maybe we can find them again. I guess, yeah, here are the limestone walls. And then we see how they got mapped and what the resulting environmental impact is from those materials. We can sort here, so we see, or we can drill down the data. I would say the most visually interesting are probably the different charts. Here you can customize it pretty heavy, I would say. You can take away certain items. You can switch to maybe a line chart if you want to, for example, show different material entities. And then we see that our walls are very much dominant here. We can maybe show it that in a pie chart, and we see, yes, those walls. If we go into the materials, we see why. It's because that stone or that limestone was actually mapped to a concrete thingy. Switzerland. So we have a pretty high impact from those limestone walls. That's not that's not reality, but that's just the mapping that I applied. You can export those charts as well. I quite like the bubble chart because if we group that by IFC material, we see that we have a lot of volume from that material, the horizontal axis, the volumes, and on the vertical axis, we see the environmental impact. So that's probably the thing I would target first when I'd optimize. Then I wouldn't really look at these because they don't really have an impact. We can print those. You can download these, save as PDF. And I'm working on a reporting system where you can kind of generate reports and also export lists. Yeah, that's pretty much it. We do have our three indicators, which are global warming potential, non-renewable primary energy in kilowatt hours. That's just how we do it in Switzerland. I am aware that that's different from the rest of Europe. And then we also have the environmental impact points that are also a Swiss thing. So I would mainly look for, or I would mainly optimize for global warming potential. And when I'm working on implementing EcoBauDAT, I will have global warming potential, primary energy, non-renewable, and probably primary energy total, because the environmental impact points that don't exist only in Switzerland. Yes, that's already it for my short demo. I do have a few more slides that I can go through. Maybe we do have some questions. You're muted, Petru.
We have only one question so far, so I can get that one, and then you can move on over the other slides you have, and then I can also ask some questions because I have few. Does the mapping algorithm map all the materials correctly, or we have to accept and check it to assign the correct EPD?
Based on material naming. So whatever you use inside of your IFC model, I am just looking at the name, and then I am doing a fuzzy matching that works. It looks at the difference of the text. So it basically just tries to find a similar material. But I would say it's not that intelligent currently. I did, or I did some experiments also with large language models, but I do find that the return that we get here is kind of limited because as much as I would like to have the fully automated LCA, you press a button and it spits out a perfect result. We have to be aware that if you want to achieve a certain level of certainty, it will always require some specialist who sits down, looks at the materials that are available in the database, and figures out how they can be applied to what's actually in those models. So I see a kind of a diminishing return here. I do see potential, but it's not top of my list. For me personally, I do LCA for some pretty big projects here, and I set it up once in the beginning, and then every subsequent upload, they just get applied. I usually check them, and if the modeler, if they introduce new materials, those will pop up, and I will have to assign the correct environmental impact indicators for those. And currently, no EPDs, and also not planning to use EPDs. I am only using official, I would say, collections of EPD data. So I will be adding Ökovaldat, where we can find where we can find a lot of EPD data, but it will not be possible to use a certain EPD directly.
Okay. Yeah, thanks for the reply. We got another question in the meanwhile. Fernando is asking, can we upload or use another materials database or only the Swiss one?
Currently, it's only the Swiss one. You can always fork it and introduce your own DB, and you feel free to reach out if you have something in mind. I do have the Ökobaldat pretty much ready, and that works quite well. But yeah, feel free to reach out. I'll see if I can do something.
Okay, great. You can
You're muted again, but I'll switch back to.
Yeah, it's all good. You can keep going with the slides that you still have, and then
Thanks.
I'll ask a few questions myself.
Perfect. So yeah, pretty much covered this already. I am using IFC OpenShell in WebAssembly, which means it's encapsulated. No IFC data leaves your browser. I am planning on adding 3D, and I'll probably be using 3JS for that and Engine Web IFC from that open to have client-side IFC parsing with full geometry in 3JS. The whole thing is built with Next.js and React. I host on Vercel, which means serverless, and I use TypeScript and Clerk for authentication. What I wouldn't recommend is running your own auth. I've tried that in the beginning, and yeah, those are kind of the learnings.
What do you mean?
What
What do you mean to run your own?
I've I've implemented a full authentication system. I've
Ah,
written it myself, which means
ah,
like password hashing, email, sending out email, and then checking if those people are the real deal.
hmm.
And I mean, I didn't know, but that's a service that we can use today that is 100 times better, more secure, and it's free, and it's secure. So it's a win-win for the users and the developers.
Yeah.
Yes. But yeah, IFC LCA is free, it's open source, and I do maintain it in my spare time. So there is some things missing. As we've discussed, a 3D viewer would be very nice. I am working on connecting that to the results. Additional impact data will come, and also being able to actually do like certification is something that is currently not possible. I'll get into the details. I am looking into getting it kind of validated through some academic collaboration. And I'm also working on a bonsai or yeah, a bonsai plugin
Oh,
where we have IFC LCA inside bonsai, which
wow.
means you can just use, or you could just load the active model, connect to database, and have the LCA fully inside there.
That's amazing. Well
Thanks.
done. Well done.
But yeah, as I mentioned, the devil is in the details, and what we've seen before is kind of not the full picture. If we have to do, or usually in Europe, or if you follow some sustainability labels, they usually tend to look at an LCA per square meter and a year, which means we get kind of this time factor in where certain parts of the building will last longer and therefore will have less of an impact. So you have to know life expectancy per element and also have to know square meters of the project. And that's currently one of the things that I'm also working on. In Switzerland, there's a methodology where we can get life expectancy from classification inside IFC models. And there I try to kind of close the loop so that this gets more usable in practice. Yep. Feel free to check out sources and additional resources if that's interesting for you, or feel free to reach out if I went too quick on something. I'm more than happy to explain in detail.
Hmm. I was thinking about something, Uh, this tool is also good to be used, for example, to understand how good is your IFC model, just like without just drag it in and see the report, and you'll see immediately how good or how bad is your model, right?
And what materials you used exactly, and also a nice element overview and how those
Mm,
materials are distributed. Yes, I agree.
yeah.
Might even be beneficial if you're not that, or the environmental impact analysis can actually be a byproduct.
Hmm.
Yes, agreed.
Yeah. Um, yeah. Great stuff. What are the next steps? What do you plan? Like, what is in the roadmap right now? What are the priorities that you have?
I am kind of torn between 3D and more data, but I'm getting pulled towards more data um, because I just feel like this will open up the possible user base. When I add about that, all of a sudden this gets a lot more usable for a lot of people. So that's probably my first priority. And then I feel like, yeah, we need a 3D viewer because then we can actually like reap the benefits that we have by being model based.
Yeah. Yeah.
What I do myself, if I do LCA for building models, is I sometimes even add results to the IFC itself. So I would write global warming potential to the correct P set according to
Mm,
BSDD, and that then allows us to be totally independent of any analysis system because you can use whatever you usually use. You can maybe you have like a I don't know, Power BI dashboards or something like that, you feed from IFC, or you can just create lists from in your IFC viewer, um, or you can also upload it to IFC Flow and create some nice charts there.
mm. All right.
So the IFC can actually also be a container for the results, which I'm not doing currently. I'm just reading the IFC, looking at
Uh-huh.
the materials, and then presenting the result to the user.
Mm-hmm. That's not a bad idea, to be honest. I think that would be cool, to have that option. Of course, wherever you'll get the time to do, I'm sure you have all these apps that now we're talking about prioritizing features or things for this one, but you have all this ecosystem of so many apps. So I don't know how you prioritize those. But what about the Bonsai integration of the tool? Like, kind of, if you throw a date or a month, where do you
I'm
think
not
would be
gonna do
possible?
that,
No.
unfortunately. So
Before Christmas, any chance for that to happen before Christmas?
I don't know. I have to talk to Dion first.
Ah, okay,
Um, he was very encouraging, I'd say.
okay, yeah,
But yeah,
okay.
let me see if I can pull up some.
Yeah. Meantime, guys, if you have any other questions, now is the time to ask it, because after that we're wrapping up. So if you have any other questions about the tool, like you know already, it's free, open source. You can use it, modify it, contribute to it, whatever, right? Provide feedback. Uh, Send me feedback if you want. Send to Louis directly. Send him an email. Contact him on LinkedIn. Me on LinkedIn as well. Like, it doesn't matter. On GitHub even, right? Do you get, by the way, any issues created by other users than you? Sometimes, yeah.
Yeah, it's mostly developers that are users on my
Uh-huh.
tools.
Uh-huh.
But yeah,
Okay. Yeah. Okay.
um,
This
it's
is
not a
how it could
problem.
look.
Yeah, that's yeah.
Wow. But
So
I
you
guess
just
you have it right now as a complete separate plugin in Blender. Not has nothing to do with Bonsai, or
it does, but
it
it
does?
only runs on my machine.
Ah, okay.
So so to actually get that integrated so that Dion is happy to publish it will take some work.
Yeah.
Um,
Yeah.
but yeah, what I do is you can just load the active model, or you can load a different one.
Uh-huh.
It will get all the materials, gets you the materials into a list. Uh, then you can search the about that, which we see here. Um, so you actually see like or you through the API you can get environmental impact for different materials.
Hmm.
You can pull those in. Then you can calculate embodied carbon and whatever else. And you see the results down here, which is kind of limited. And we now have the possibility to work with a small web server where we can send data from Blender to the web. IFC Open or Bonsai does that too for like I think the QTO and stuff,
Hmm.
or also is it the task planning where you click and it will open on your browser? And I'm doing just the same, just to have those nice charts, etc. And yeah,
Hmm.
to have the nice overview.
I
But yeah,
understand.
that's basically it.
Looks very
And
cool,
it
man.
works exactly same as online.
I'd love to see it.
Thanks.
I'd love to see it inside. Like that. That's going to be nuts.
I have to
Um,
chat with you.
yeah, yeah. Um, okay. We don't have any other questions. I think we can wrap it up. Is there anything else we could do about this one? Um, like that's the use case, right? How does it work when we have more models?
You can combine different models. Um, so you can upload more than one, and those will live in one project. But oftentimes it's actually um, favorable if you separate them.
Uh-huh.
Um, but
Especially
I
different
mean,
disciplines. But if you have, for example,
that's
more
what I was
structural, yeah,
thinking. Yeah.
okay, yeah. But if you have
But
more
if you have
structural
like
ones, yeah.
a different concrete pore zones or something, yeah, drop them all in, and those will get analyzed. You can apply the different materials to different models,
Mm.
and yeah, I mean, with LCA, people tend to think that it's a lot harder, but it's actually not rocket science. And there are tools that you can kind of dip your toe into this world. And I would encourage everyone who's interested to do that. Never, or I don't care what tool you use. If you use my tool, more than
Mhm.
happy to. But I think it's our shared responsibility in this industry to at least measure what we do, because as great minds have said, we can only manage what we measure, and also we can only improve what we measure.
Mm. Mm. That's so true, man. That's so true. Yeah. Thank you very much again. Thank you very much for the wonderful work that you do. Thank you very much for taking the time again to share this with us, with everyone. And yeah, I really appreciate everything you do. Your efforts that you are making. You are really making a big impact in the industry, and you are motivating more people to do the same. Hopefully, at least you motivate me to do more. So
That
uh,
goal achieved, Petru.
everything starts there,
That's
right?
enough.
Yeah, 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 yeah. Thank you so much, Lei. Thank you so much, everyone, for taking the time and joining us. Stay in touch.